LDA is a technique that reduces dimensions while keeping different classes separately from each other. Welcome back to my channel. Hope you all are doing good. Today we are going to start with the first session or the first video on our classification algorithms, and we are going to understand on linear discriminant analysis or LDA. Guys, while subscribing, do not forget to hit the bell icon because the contents are going on regular basis. You will not miss them if you will do that. So let us start with our topic today. Let us start on our topic on linear discriminant analysis. And before moving ahead, guys, I have already covered the logistic regression one, and that logistic regression again is a classification algorithm. It's not a regression algorithm, just like the other one, like linear regression and elastic net and like that. So that one I have already covered. If you have not gone through that, please go through that video and understand the concept, how our classification algorithm works. That is again binary classifier, and we have multi-class as well for that, but that is considered only for binary classifier most of the times. And today we are going to understand the second classification algorithm, which is nothing but a linear discriminant analysis. It's one of the important algo if you consider, a case of imbalanced data and, in terms of classification part. So let's explore on that. So what is a LDA, guys? LDA is a, it's again known as a normal discriminant analysis, and it's a supervised classification algorithm. What it does, it helps the two or more different classes. It is going to take them and it is going to separate it out from the higher dimensional space to the lower dimensional space. So the job of this is, whatever the classes you have in your target variable, it's going to take them and it's going to separate them. And when we are talking about target variables and in terms of space, you don't know what kind of dimensions and how it is getting worked, but when we are talking about dimensions, usually that is going to be always a higher dimension when we are talking about space. And that spatial formation, you are converting that to lower dimension, maybe 2D, or you can come down to 1D as well, like with your linear discriminant analysis. And it is used, specifically it is used to identify the linear combination of features. What is the difference between linear combination and non-linear combinations, guys? We have gone through all these concepts during our regression. So when I'm talking about linear combination, what is the meaning of that? When we're talking about linear, that is nothing but the features, whatever the features we are considering, they are behaving linearly. That means when one feature is increasing or, the direction is increasing, the other feature's direction is also increasing in the same way. That means they are following a straight line relationship. However, when I'm talking about the non-linear combination, mostly they are following the quadratic, which we understood during our polynomial, right? They are showing the curvature formation or the curvature formation of the behavior is your non-linear combination. So here mostly the features which have been considered here, that should behave in linear fashion, and which helps to separate the classes within the data set in case of LDA. So here one example I have shown in this image. So if you see, we have two different classes, right? One is a circle and another is a plus. And you can see that it is created, 2D form, like this is one form, this is axis, right? This is LD1 is one axis, LD2 is another axis. And you can see how nicely it has separated these classes. So this is again in case of binary class. If you have multi-class as well, in that case also it can handle the things really nicely. So the simple concept here is, it is separating two or more classes. How it is separating? It will convert all the high dimensional spaces to the lower dimensional space. That is all. And there are so many different techniques we have during our ML intro I have explained you that we have dimensionality reduction techniques just like PCA, right? The PCA technique is completely different as compared to this. However, this is only for classification which you are using, right? So let us understand on what are the assumptions which you are considering for LDA. So when we are performing something, right, some algorithm on some features, we are going ahead with some assumptions, and all those assumptions and techniques we understood for our previous algos. So the same thing we are going to talk about in this. So the first one is a Gaussian distribution. So whatever classes, the target classes which you are considering, if it's multi-class, whatever the single class is present in that are going to follow, should follow a normal bell-shaped distribution. What is normal bell-shaped distribution, guys? It's just this, right? If this is the thing, this is my normal behavior, right? Sorry, this is mu. These are standard deviations like that. So, this is your Gaussian form, correct? We studied throughout our, journey about this. Then what is the next step? What we should have equal covariance matrix. What is the covariance, guys? Covariance is the relationship between the features. So all the classes which you are considering should have good relationships among themselves. If you are considering the structure wise and the characteristics wise, everything should be same when you are considering the LDA. Then I already mentioned that the classes or the data should be in such a way that it should be separated using just a plane or a straight line. That's it. And independence, like all the features should ideally be independent of each other. The features should be independent of each other. So we understood about Gaussian distribution, covariance matrix. It should follow the same covariance matrix. It should be linearly separated, like it should follow the straight line, and one straight line should separate out the classes. Then the features should be independent to each other. Here I have shown one example, if you see in a broader way, that we have different features here, right? This is a plane, like this is your independent variable and this is your dependent variable, and my dependent variable are classes here, right? These are classes, and these classes, what are the things present here, guys? I have different classes of a black dot and a green dot. So in this LDA, it was created a line, right? And that line, it is separating out. So how it is going to separate? So first it is going to understand the distances. So you can see this black dot is having longer distance, then this black dot is having a longer distance. So whichever, first it will check for each class, or it will segregate each class. So it will just take this and this like that. Then after that, what it is going to do, it is going to understand the distances. So whichever interclasses. So we have this black class, right? So all black classes distances or the variance, it is going to reduce, and it is going to take to this. So this will be shifted this will be shifted to this one is going to be shifted to this. If this is already here, then it will not do anything. So the dots which are closer to this line, it will not do anything. However, the dots which are having distances or better distances from this line, it is going to draw to near to that, or it is going to put all those lines near to this, all those dots near to these lines. Similarly, the case is same for this class. So it is going to, after everything, it will tell, okay, I have two classes and based on this characteristics. So the characteristics is what here, guys? We have color. So we have black color and green color. And you can see that this is how it was presented in 1D format. You can see it has segregated out to green dots and black dots. So that is how it works. Then what are the limitations and what are the key concepts? So again, when we are considering any algorithms, we should be having some limitations, right? It's not everything is perfect in this world. So those limitations are going to be, sensitivity to data distribution. So when we're considering like the distribution of data, it must follow a Gaussian distribution. If it is not, LD will not perform well in those cases. Then multi-collinearity features. So the features which are highly correlated, then the performance of LDA will be affected, right? Then you cannot use this with highly complex data. Like if the data is highly complex, if the relationship between the features are highly correlated, then if the features are presenting in a non-linear relationships, then LDA will struggle to classify the output, or the classification of output will be difficult in this case. Then we have few key concepts which are considering here. So what are the key concepts, or how we are achieving this? These are the steps. So one, it is going to consider the class variance. So it is going to get the difference, or the class variance should be maximized, right? LDA maximizes the separation between the mean of different class. So it is going to take mean of all the features and it is going to separate it out from different classes. Then it is going to minimize within class variance. Like I've already said that it is going to group it. Then after that, it is going to take the interclass variance. It is going to take care of the interclass variance. It is going to understand the differences, whatever the differences it has. It is going to put them in closer to that line, right? Then we have we should, whatever the final LDA or whatever the output it will create, that it is going to project it in a new axis or the space or the plane. So suppose if you have a 3-class problem, then LDA will try to reduce it to 2 or 1. If you have 4-class problem, it is going to try to reduce to 3, 2 or 1. So with this, it is going to preserve the class related information. It is going to reduce the dimensions, right? Then before moving ahead, when we are talking about these dimensions and dimensionality reductions, we should understand the concept. What is the meaning of dimension exactly, right? When we are talking about dimensions, specifically in case of AI, these are nothing but the number of dimension a space has, or the number of features in dataset. Let me take you to the whiteboard and explain you the perspective of this. When we are talking about dimensions, suppose if you have suppose 10, we used to have more features, right? So just take you have 50 features. 50 features. So when we're talking about dimensions, how it is behaving in space or in the spatial form. So it will take this plane, suppose. So all these features are going to be presented like this vectors, right? All these features. So if you have 50 features, you will be having 50 dimensions here. You will be having 50 dimensions like that. We don't know in which direction that's getting presented. This is a black box. We cannot see that. So like that, you will be having 50 dimensions. So whatever features you have, it's going to create those many dimensions when it is coming to the machine. We cannot see that. That is why all these algos and all these techniques are written, so that all these dimensions will be converted to the or the reducing of the dimensions will be there, and that's why dimensionality reduction comes into picture. And everywhere that is happening, in all algos that is happening internally, whatever features are there, that's why we are getting coefficients. In case of linear regression or regression concept, we are getting coefficients. Those coefficients are what, guys? Again, those are the formation. Like we are understanding, okay, when we are drawing this line, and these features are somewhere coming in 2D format, right? These are my features. So that's how my dimensions on the dimensionality reduction both are coming hand in hand together, right? So the same thing here I have explained that suppose this is a data set, right? This is a data set, and this the data set is converted to 2D, then this is 1D. And how it is getting converted, we cannot see that. Again, we have all these techniques, we can just understand the concepts, how machine is behaving, what machine is doing. We are out of the way, we cannot see that. So that is what our dimensionality and dimensionality reduction, both things I have explained from that example. And even in this example also, if you see that we have 4 different classes here, right? 4 different classes. This is a plane, or this is a, what I can say, space format presentation. And if you see in 2D, this is how it looks like, right? If you need to imagine. Then when we are converting that to 1D, this is how it looks like. And the plane which we are drawing, most of the times I used to tell that, the points are, in overlapping format. But you will see from 3D format, it will look in a scattered way, right? And again, this dimensionality reduction has so many benefits, right? When we are performing this, it is, see, when the dimensions are converting to lower dimensions, it is definitely going to improve the performance, right? And it is with this approach, we are not reducing, or we are not losing any of the essential properties of the features. It is preserving the features at the same time, properties of the features at the same time. There, it is helping to reduce noise. Noise means the error part, or the points which are very closer to the lines which it is forming. Definitely it is reducing the distances or the errors from the actual value, right? And we are coming closer to the identifying the classes here. Then visualization, it is better in understanding how our data is getting visualized or present in that space. When we're talking about 1D, then it is very clear, right? We have 4 different classes, and here in this example we have blue, then yellow, then green and red. Better. Then data compression. With this, we are compressing the data. That is one of the important factor, right? So this is nothing but dimensional reduction, and with LDA we are doing a dimensionality reduction in the other way, right? And we have another techniques as well, like PCA, principal component analysis. So those things again we'll explore, but let's explore the other things on how our LDA works, how our discriminant analysis algo works. So I have already explained you this, but let's understand on mathematical form how it is working. So first it will find a new axis. When you have target variables or different target classes, it will find a new axis, and that axis, like I have already explained, it is going to maximize the between class variance while minimizing the within class variance. Suppose, let me draw here. This is my class. This is my, I have cross, just the same example I am taking, and this is my circle. My circle is present there, my cross is present like this. So first it will do one thing, it will create a line like this. Okay. Then once it is creating that line, what it will do? It will first separate 2 classes. Like I have already said, it is just going to create 2 different like this. Then it is going to maximize the distances. It is going to maximize this distance internally, and it is going to minimize this distance. Whatever the distance is, like I have already said, that this distance it is going to try to fit it closer to this line, and it is going to increase the distances between these 2 groups. That is what the meaning when we are talking about maximizing the between class variance and minimizing the within class variance. Then what is the next step? It is going to compute the mean vectors. What is a vector, guys? Here vectors are nothing but a features. So each class's mean it is going to calculate. Then it is going to find out the scatter matrix. Then like it is going to create two scatter matrix, right? One between class and one within class, just the way I have shown you. Then it is going to project that vector by converting that into a another formation, or it is going to reduce that to lower dimension, and it is going to project that by confirming that new axis. So that is how it works, guys. And do you have to remember this formula? Just remember the technique. Don't have to use, we are not using these formulas anywhere, but it is better to understand these techniques whenever it's coming. Then what are the different applications we have? We have again various way of uses in different sectors of LDA. We are using this in face recognition system, where we are using this biometric system to identify the users. Then it is helping to predicting different stages of cancers or heart diseases, right? Then customer identification, which group of customer is purchasing better more, then we can say provide special discounts and all in case of marketing. That's a marketing strategy, right? Then credit risk assessment, the fraud risk assessment, then quality control in production system. So whenever these industries are working, or the product based industries are working, they are following, once the products are created, they will go ahead with this quality inspection, and it is this one will help, or this LDA will help to segregate which products are better or the best out of that lot and which are not. Then in case of campaign optimization, which sector we can go ahead and we can increase our campaign, which sector is less response we are getting, all those things we can achieve through LDA. So it has a wide range of applications. What are the pros and cons of LDA, guys? Again, every algo has some advantages and disadvantages at the same time. So I have already explained so many advantages are here, like it is very easy, just the way it is reducing the dimensions. It helps in what I can say, suppressing the features, and the features are not losing its characteristics or the main characteristics of them. So that's how it is maintaining the simplicity. Then it provides on what way it's classifying that the features. Then it has better computational efficiency. It is less intensive and very useful in case of large data sets as well, and works well with linearly separable data. So if you have most of the data sets which we are working, those are linearly separable only. So those cases it is going to work well. Then we have few disadvantages as well. So it's sensitive. So whenever we are performing LDA, we are just assuming that all the features which are there are following the Gaussian distribution. That's assumption. But in real scenario, it is happening or not, we cannot see that, right? So wherever non-linear relationships features are there, it is not going to perform well, because the default way of understanding LDA is a linear relationships of features. Then if you have imbalanced class, it is not going to perform well. You should be having a equal distribution of classes. If you have four feature classes of output, then all features or all classes should be having equally distributed. Then if you have outliers in your data set, it is not going to perform well in that case. So different evaluation matrices here we are using, and these are the common matrices which we are performing in case of algo classification algos. So one is accuracy, that's very important. Accuracy, just the way we are using R2 score, accuracy is going to give you that, the overall correctness of the model. Then precision, recall, then we have, this is sensitivity. Recall is called sensitivity. Again, we have specificity. Sensitivity is going to tell you the positive Then specificity is going to tell you the negatives. Then we have F1 score. It's the balance of precision and recall, and balanced accuracy. Then ROC, AUC, log loss, MCC, Matthews correlations coefficient, Cohen's kappa, right? Then confusion matrix. That's the base. Confusion matrix is all combination of true positive, true negative, false positive, false negative. Then what is ROC? ROC is receiver operating characteristics, and AUC is nothing but the area under the curve. So all these metrics we are going to explore in our future videos. So we have completed our LDA and its concepts. We will meet during our real-time example. So see you till that time. That is all for now. We will cover the real-time example of LDA, how LDA works, and what are the concepts, what are the features, everything we will explore practically during our next video. If you really like the content, guys, please go ahead and start subscribing, like, share your comments, share your valuable feedback. Please hit the bell icon while subscribing so that you will not miss the latest updates, because the contents are going on regular basis, and all these contents are really important for understanding on future perspective. So see you till next time. Bye. Take care.